The American flower trains and accessories were designed in the 1940s and 50s to be made at a price, but they provide a lot of play value for the price. I like to imagine how the realism could be improved had the modern microprocessor existed at the time. My microprocessor of choice is the Arduino, which can use very simple sketches to provide increased realism. This is my attempt to make the 759 danger bell and 761 crossing provide a wig-wag style of operation. I had to modify both of them slightly by splitting the contact on the back of the lights to allow them to be lit separately. The sketch provides a 50 millisecond pulse to ding the bell and a 250 microsecond on and off time for the lights. The short pulse for the bell reduces coil heating, which caused many of these toys to burn out if the train was inadvertently parked on the track trip. I made some custom printed circuit boards to mount the circuitry. It uses a bridge rectifier to rectify the 16 volts AC from the transformer, then a small buck converter to regulate the DC to 5 volts for the processor. I wanted to make sure that the 16 volts AC did not damage the microprocessor, so I used photo-opto-isolators to drive the triacs, which drive the lamps and bell. So when the train passes over the standard 696 track trip, you can see that it starts the bell dinging and the lights flashing. And after the last set of wheels is passed over the trip, the processor continues for a few seconds to allow the train to clear the crossing. This is much more realistic than just the click-click style as originally designed. Also, if the train is parked on the trip, it continues to ding and flash, but it won't burn out the coil. In a future version of this board, I may include an additional track to operate the crossing arm and crossing grate. Okay, now it's cleared the track trip, and so it should stop after a few seconds. You may notice that the caboose lights don't flicker as they go back and forth. That's because I also use the same buck converter and LEDs in the caboose. I may cover that in a future video. If I can master another circuit board design program, I may take advantage of the companies that offer printed circuit boards to be made at $2 or so per board. Then I may offer kits so that others can build the same circuit. The circuitry just uses the standard American Flyer trips and transformer voltages, so it can be added to any American Flyer layout. Thanks for watching.